Okay, today we're going to be working on CC1 1.2.3 review and preview. Our first problem is number 1-68 or 68. Harry had a pile of 48 pennies. He organized them into a rectangular array with exactly 4 rows with 12 pennies in each row. We need to draw diagrams to represent at least 2 other rectangular arrays he could use. And then we need to answer the question, do you think there are more? Explain your thinking. So he organized them into a rectangular array with 4 rows of 12, which is, we could think of it as 4 times 12, which is 48. Are there any other combinations that get us to 48 when we're multiplying? I know it's an even number, so 2 goes into it. So 2 goes into 4 2 times, and 8 4 times. So 2 times 24 is 48. And then, if you don't know this trick, pay close attention. So if I take the digits 4 and 8 and I add them together, 4 plus 8, it's 12. Because 3 goes into the number 12, I know that 3 goes into 48. Okay? Now I might have to use some division here or look at my multiplication chart. 48 divided by 3. 3 goes into 4 one time. Well, 4 minus 3 is 1. 3 times 6 is 18. So it's 3 times 16. I'm going to draw my rectangular array for 2 times 24 and 3 times 16, or 2 rows of 24 pennies. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I can do 2 rows of 24 pennies. That. Or I can have 3 rows of 16 pennies. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Three rows of 16. Do you think there are more? Well, yes, I do. But I want you guys to explain why there would be more. Okay. So for number 69, for each of the number of pennies below, arrange them first into a complete rectangular array with no leftovers, and then into a different rectangular array that has a remainder of 1. So there is 1 extra penny. And then we need to write an expression for each arrangement. So 10. Well, I could arrange it in 2 groups of 5. That's 10 pennies. But if I want to have a remainder of 1, then I'm left with 9 pennies if I have a remainder, which means that 3 groups of 3 would get me 9 pennies plus 1. So this is 5 groups of 2. This is 3 groups of 3 plus 1 left over. Part B, I have 15 pennies. Well, okay, I have to think. Well, what times what is 15? Well, five groups of 3. So I could have 5 groups of 3. But if I want 1 left over, I'm left with 14, which leaves, I could do 7 groups of 2, or, so then I don't have as many groups of 2, I could do 2 groups of 7 plus my 1 word left over. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm going to move my dot, my extra over here. 25 pennies. Well, I know 5 groups of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 groups of 5 would get me 25 pennies. But now I have to do it with a remainder of 1, which means I'm left with 24 pennies. Well, I could do 2 goes into 24. 2 groups of 12 plus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could do these all different ways. There's more than one way to get to 24. I could have done 3 groups of 8 plus 1, or 4 groups of 6 plus 1. Okay? There's not one way to do it. Okay, moving to problem 70. How many pennies are represented in each expression below? Okay, order of operations says I'm going to do any multiplication first. So I'm going to look at 4 times 5 first. 4 times 5 is 20 plus 3 gives me 23. Part B, 4 times 3 is 12 plus 7. 12 plus 7 is 19. Okay, part C, I'm going to look for all multiplication first or parentheses first. 2 times 3 is 6. And then I have parentheses over here with 4 times 2, which is 8. And then I can add them all together. 6 plus 5 is 11, plus 8 is 19. Using whole numbers, fractions, and decimals, write at least 8 addition equations that have a sum of 10. Write more if you can. I'm going to go through 4 of them, and I'm going to have you go through the remaining 4. Or more if you can. So I know 5 plus 5 is 10. 1 plus 5 plus 4 is 10. Right? Because 1 plus 5 is 6. 6 plus 4 is 10. I could do 5.5 plus, well, I might have to do that. So 10 minus 5.5. 0 minus 5, I can't do it. I have to borrow. I can't borrow from this 0, so I have to borrow from the 10's place value. And then borrow again. 10 minus 5 is 5. 9 minus 5 is 4. I carry down my decimal point. 5.5 plus 4.5 is 10. So, number 4, I could have 1 plus 1 plus 1 plus 7. 1 plus 1 plus 1 is 3, plus 7 is 10. I'm going to let you figure out the remaining 4. Then we're going to move to the next problem. It's the last problem. So we need to use our knowledge of place value in decimals to place the correct inequality sign, less than or greater than, between each pair of numbers. So I have 5 and 207 thousandths, or 5 and 27 hundredths. Well, 27 hundredths is bigger than 207 thousandths. So I'm going to say, I'm going to use the less than sign. 3 and 6 thousandths, or 3 and 6 hundredths. Well, hundredths are bigger. 2 and 408 thousandths, or 2 and 40 hundredths, or I could put a 0 here because I didn't change the number, and 2 and 400 thousandths. So 408 thousandths is bigger than 400 thousandths. I'm going to round each of these numbers to the nearest tenth. So I'm going to find the 10th place value, underline it, and look to the number next to it. If the number is 5 or larger, I'm going to change the underline number up 1. If it's below, if it's 4 or under, it stays the same. So in this case, the number I'm looking at is a 0. It stays the same. So it's 3.3 and 0 tenths. Part 2, I'm going to still look at that 0, but now my number's larger. My 0 goes up 1 to 3 and 1/10. As always, if you have questions, do not hesitate to come and talk to me.